Most people imagine that if they ever found a real meteorite, they would know immediately. They picture something dramatic, a strange metallic rock, a perfect black shell, maybe even a shape so unusual it practically screams that it came from space. But the truth is much more frustrating and much more interesting. Some of the most convincing real meteorites do not look spectacular at first. In fact, many of them are ignored for one simple reason: people are looking for the wrong kind of surface. That's the trap. Because when most beginners search for meteorites, they focus on the big fantasy clues. They want obvious metal, they want a perfect shape, they want something that looks like it fell out of a science fiction movie. But real meteorites often don't reward that kind of thinking. Many are subtle, many are rough, many are weathered. Many look so ordinary that people walk right past them while picking up the fake rocks instead. And that's why surface clues matter so much. Because the surface is often where the real story begins. If you know what to look for, the outside of a suspicious stone can reveal signs of heat, violence, atmospheric entry, density, and a journey that may not have started on Earth at all. And if you ignore those surface clues, you can miss the one rock that matters while filling your pocket with things that never had a chance. So today, we're going into the surface clues of a real meteorite that most people ignore. Not myths, not wishful thinking, not this black rock must be from space because it looks weird. Real visual clues that can help you slow down, read the stone better, and stop getting fooled by every heavy dark rock that shows up in the dirt. And the first surface clue most people ignore is not shine. It's skin. A real meteorite often carries a surface skin that tells a very specific story. This is what many people know as fusion crust. When a meteorite enters Earth's atmosphere, it experiences extreme heat from friction and compression as it tears through the air at incredible speed. The outer layer begins to melt. That melted surface then cools and solidifies as the meteorite slows down. What you get is a thin outer shell, often dark, sometimes black, sometimes brownish black, sometimes slightly glossy, sometimes matte depending on weathering and age. And here where people make the mistake. They think fusion crust should always look fresh, smooth, and obvious. It often doesn't. A newly fallen meteorite may have a cleaner, darker crust that stands out strongly. But older meteorites that have spent years, decades, or even much longer exposed to weather can lose that perfect burned look. The crust may become patchy, it may crack, it may dull, it may blend more into the stone, it may look almost dusty or worn, and that is exactly why many real meteorites get overlooked. People expect perfection. Nature usually gives them evidence instead. So if a suspicious rock seems to have a thin, dark outer layer that feels different from the interior, or if the outer surface looks naturally heat-worked rather than just randomly darking, that deserves attention. The second surface clue most people ignore is texture consistency. This is huge. A lot of fake meteorites, especially slag and industrial waste, can look dramatic because they have rough surfaces, dark color, and strange melted shapes. But when you really study the surface, something feels wrong. Slag often has a chaotic, messy, bubbly, or foamy texture. It may show obvious gas holes. It may look like it once cooled from a fully molten industrial process with trapped air. In many cases, it looks irregular in a way that feels artificial. Real meteorites are usually different. Even when they are rough, they often feel dense and purposeful. Their surfaces may be irregular, but the irregularity often has a tighter, more controlled appearance. The stone may look weathered, sculpted, or naturally ablated rather than foamed or inflated. That's a subtle but powerful difference. A real meteorite surface often looks like it has been shaped by heat and motion, not by trapped industrial gas. If the rock has obvious bubbly holes all over it, large vesicles, or a spongy-looking surface, your suspicion should drop fast. Meteorites can have pits and depressions, yes, but those are not the same as gas bubbles. That difference matters more than most beginners realize. And that leads us to one of the most famous surface clues of all, the clue almost everyone has heard of, but very few people understand correctly. Thumbprints. The technical term is Regmaglypts. These are shallow, rounded depressions that can appear on the surface of some meteorites. People often describe them as thumbprint-like marks because they can look like someone pressed fingers into soft clay before it hardened. These depressions form during atmospheric entry as parts of the outer surface melt and ablate in uneven ways. Now here's the important part. Not every meteorite has obvious Regmaglypts. That's one of the biggest misconceptions. Some have strong, beautiful thumbprint-like depressions. Some have only subtle ones, some have none that are easy to see. Weathering can reduce them. Surface damage can hide them. Smaller meteorites may not show them clearly, so you should never reject a possible meteorite just because you don't see dramatic thumbprints. But if you do see shallow, rounded depressions on a dense, dark rock, especially if those depressions feel natural, smooth-edged, and part of the stone's surface history rather than random broken cavities, your curiosity should rise immediately. This is where beginners often confuse slag holes with Regmaglypts. And that mistake can ruin a find. Slag holes are often messy, bubble-like, and obviously related to trapped gas. Regmaglypts are usually more sculpted, more shallow, more integrated into the surface, and less like random blown-out voids. One looks industrial, the other looks aerodynamic. That difference is everything. Another surface clue most people ignore is the way light behaves on the rock. This is incredibly underrated. Most people pick up a suspicious stone, glance at it once, and decide, that's not enough. A meteorite surface can change dramatically depending on angle, moisture, and light. A dry stone in harsh sun may hide details that become obvious in softer light. A slightly damp surface can suddenly reveal crust boundaries, subtle flow lines, tiny metallic flecks, or shallow Regmaglypts that were invisible before. And yes, flow lines. Some meteorites, especially fresher ones, can show delicate surface flow features caused by melting and movement during atmospheric entry. These are not always easy to see. They may be faint. They may require the right angle. But when visible, they can appear as subtle melted streaks, delicate surface movement patterns, or slight directional skin behavior that feels different from ordinary weathered rock texture. Not every meteorite shows them clearly. But if you ever rotate a suspicious stone and notice the surface looks like it once moved under intense heat, do not ignore that. That's not a normal clue. Then there's the surface break between outside and inside. This is one of the strongest clues people miss when a suspicious rock already has a natural chip or broken corner. If part of the stone is damaged, study that boundary carefully. Does the outer surface look like a distinct dark shell compared to the interior? Does the interior look lighter, denser, or more compact beneath a darker crust? Is there a clear difference between outside and inside that suggests the outer skin has a different history? That can matter a lot. Many real meteorites, especially stony meteorites, can show exactly that kind of contrast. A dark weathered or fused exterior and a grayish, sometimes lighter, sometimes speckled interior beneath it. Some may even show tiny metallic flecks under close inspection. Not always, but enough that you should look. A suspicious rock with no clear surface interior contrast may still be worth studying. But when that contrast is there, it becomes a serious clue. And now we come to something beginners almost never think about: edge softening. Real meteorites often survive one of the most violent journeys a rock can experience. They enter the atmosphere at extreme speed, heat up, melt externally, and lose material as they descend. This process can soften certain sharp edges and create a more sculpted, naturally ablated form. That does not mean every meteorite is smooth. Far from it. Many are irregular, many are rough, many are broken after impact or weathering. But there is often a difference between a rock that looks freshly fractured by ordinary geology and a rock that looks like parts of it were heat-worked, worn, or sculpted by something far more extreme. This is not always easy to see at first. That's why it gets ignored. If the stone looks like a random jagged broken rock with nothing special about the edge behavior, caution is fair. But if the edges seem strangely compact, softened in places, or naturally worked in a way that doesn't feel like simple breakage, that's a clue worth respecting. And now let's talk about one of the most dangerous mistakes in meteorite hunting: trusting black color too much. A lot of people assume dark means meteorite. That is a terrible shortcut. Black rocks are everywhere. Slag is often black. Magnetite can be black. Basalt can be black. Burned industrial fragments can be black. Weathered metallic junk can be black. Even certain terrestrial minerals can create exactly the kind of false hope that makes people believe they've found something cosmic. So color alone is weak. What matters is how the blackness behaves. Is it a thin skin or just the whole material? Does the dark surface look burned, fused, or weathered in a layered way? Does it contrast with the interior? Does it carry subtle luster changes under rotation? Does it feel like a surface event or just a naturally dark rock? That distinction matters. The best meteorite hunters are not impressed by dark color. They are impressed by dark evidence. Meteorites are often quieter than people expect. Now here's a powerful field habit that can dramatically improve your chances. Compare the suspicious rock to the rocks immediately around it. Not just by color, by surface logic. Look at the surrounding stones and ask, does this one wear a different kind of skin? Does it show a tighter, denser, more heat-work surface? Does it lack the obvious local texture patterns? Does it resist blending in? Does it feel like it belongs to a different story? That's how real finds often begin. Not because the meteorite looks spectacular, but because it refuses to behave like the rest of the ground. Rare things don't always look flashy. They often look wrong in subtle ways, and subtle is where real attention lives. So let's lock in the surface clues of a real meteorite that most people ignore. First, fusion crust or a suspicious dark outer skin. Not always perfect, not always fresh, but a surface layer that suggests heat and atmospheric history. Second, texture consistency. Dense, controlled irregularity is good. Foamy, bubbly, industrial-looking holes are bad. Third, Regmaglypts or thumbprint-like shallow depressions. Not always present, but powerful when real. Fourth, light behavior. Rotate the stone, change the angle, wet it if appropriate. Watch for crust boundaries, flow hints, subtle surface movement, or hidden details. Fifth, outside to inside contrast on natural chips or broken areas. A darker outer shell with a different-looking interior can be a serious clue. Sixth, edge behavior. Naturally ablated, softened, or sculpted surfaces can matter more than people think. Seventh, black color is not the clue, black evidence is the clue. And if several of those signs stack together on one suspicious stone, then you may have something worth real attention. But remember this, the goal is not to call every weird rock a meteorite. The goal is to stop ignoring the surface clues that make a real one different. Because most people lose before they even begin. They search with fantasy instead of observation. They want the answer before the rock has had a chance to tell its story. They trust excitement more than evidence, and the result is predictable. They celebrate the fake rocks and walk right past the ones that deserved a second look. Don't do that. If you want a real chance of finding something extraordinary, slow down, turn the stone, study the skin, respect the texture, distrust bubbles, watch the light, compare it to the ground around it. Let the surface speak before your imagination does. Because the most important meteorite clue is not the one that shouts. It's the one most people ignore. And sometimes, that clue is sitting right there on the outside of the ugliest rock in the field. If you want more meteorite clues, hidden rock mysteries, and natural signs most people miss, stay close. Because the next black rock you almost throw away might be the one that came from space.